Let's talk about fractions and how to add them together, how to subtract them, how to multiply, how to divide, all that good stuff. So let's say I have something like 1 over 2 plus 1 over 4. How in the world do I add these two things together? Well, first let's think about what these represent. So 1/2, let's draw it like it's a pie and you're going to cut it in half, right? So 1/2 is the shaded in area here. It's kind of a basic way of looking at it, right? But that's 1/2 the circle, right? Plus a quarter. Well, what's a quarter? Well, a quarter is when you split up this pie into 4 pieces like that, and you're just going to take a quarter. I'll fill in this one here. So that's 1/4. If I add these two things together, how much of a circle would I have filled? Well, from this first piece, you have this entire part on the left filled in. And from the second drawing here, you have this top right corner filled in. It should be kind of obvious from this drawing that you have 3 out of 4 spots filled in, right? Or in other words, 3/4. So the answer to this is 3/4. Now, you can't be drawing out pies every time you want to add fractions together. It's an effective way to illustrate why you get the answer you do. So let's try to make a connection here. This 1/4 pie, you could obviously say that's 1 over 4, but this 1/2 could be written a little bit differently, right? So instead of drawing it like there's 2 pieces here, what if I drew it like there's 4 pieces here, and I've shaded in 1, 2 of those pieces? 2 out of 4. Well, if you add 2 out of 4 plus 1 out of 4, of course you get 3 out of 4, right? These 2 parts plus this 1 part equals 1, 2, 3 parts, right? Like if I call this part 1, part 2, and this part 3, when you add them together, you have part 1, part 2, part 3 out of 4 sections, right? 3 out of 4. So the idea is you have this first pie here and you want to split it up so that it's in as many pieces as this pie. So now both these pies are cut into 4 pieces. You can add them together and get an answer, right? So there's a way to do this without drawing the pies, right? It's called finding a common denominator. So if you have 1 over 2 plus 1 over 4, and you want to add these together without drawing the pies, what you say is, I want a common denominator. The denominator is this part of the fraction down here, right? The top is the numerator, the bottom is the denominator. So when I want a common denominator, I want to make these the same. So the question is, how can I make 2 look like 4, right? How can I turn 2 into 4? Well, all you got to do is multiply it by 2, right? 2 times 2 is 4. Problem is, if I multiply the bottom by 2, I have to do the same to the top. Otherwise, this fraction no longer represents a half. It represents 1 over 4, which is a quarter. It's not the same. So I got to multiply the top by 2 as well. So whatever you do to the bottom, you do to the top. So what's 2 times 1? 2. What's 2 times 2? 4. So 1/2 is equivalent or is the same as 2 over 4. Those mean the same thing. But now what I'm able to do is I'm able to add these fractions because they have the same denominator. So when you want to add 2 fractions with the same denominator, you keep that denominator the same, so just keep it 4, and then you add the tops, or the numerators. 2 plus 1 is 3, so you get 3/4. That's the process we're going to use to add fractions. So let's do some examples. Let's say I have 1 over 3 plus 2 over 5. So in this case, I can't really multiply 3 by anything to get 5, like a whole number, you know? So what I'll do is I'll think, okay, maybe there's a number I can get both of these numbers to turn into, right? So you got to think, what's a number that 3 and 5 both go into? And an easy way to do that is just by multiplying 3 and 5, right? 3 times 5 is 15. So I could make both of these denominators into 15, right? Multiply this 5 by 3, and if you do it to the bottom, you got to do it to the top. Multiply this 3 by 5, and again, if you do it to the bottom, you got to do it to the top. Because now, what do I have? 5 times 1 is 5 over 5 times 3 is 15, plus 2 times 3 is 6 over 5 times 3 is 15. Now they're both over the exact same denominator, and I can add them together, right? So the bottom is going to be 15, and the top is just going to be 6 plus 5, which is 11. So your final answer is 11 over 15. That's a nice trick, right? It allows you to add any 2 fractions that you want. So let's do another one. let's say I have a third plus a sixth. That's the same kind of process as the first one we did, right? So 3 and 6. Well, I can make 3 into 6, right? I can just multiply it by 2, like that. And I'll have 2 over 6 plus 1 over 6, which is 3 over 6, right? And now that's not the end of the question, though, because you always have to reduce your final answer. So 3 over 6, can I reduce that? Yeah, 3 over 6 reduces to a half. If you're not sure why that is, you say, can I divide something out of both of these numbers? Yeah, I could divide that by 3 and divide this by 3, and I'd get 1/2. So this fraction reduces, is what we say, to 1/2. So that's kind of an extra step you have to do sometimes. So check your final answer. Make sure there's not a number that goes into both of those. Like in this example, you could put a 3 into both of these numbers, right? So we have to reduce it to a half. All right, let's look at another one. Let's say I have 1 over 3 plus 1 over 2. I can't make 2 into 3. I can't make 3 into 2 just by multiplying by a nice number, right? So I have to find a number that 3 and 2 both go into, which the easiest way to do that, again, is just multiplying them together. 3 times 2 is 6. So I'm going to say, okay, I'm going to make both these denominators into 6. So I multiply that by 2 and that by 2. I multiply this by 3 and that by 3, right? You're just multiplying by the other denominator, right? So on this side, we're multiplying by 2 because that's the denominator here. On this side, we're multiplying by 3 because that's the denominator here. That's kind of an easy way to think about it as well. So 2 times 1 is 2. 2 times 3 is 6. Over here, I have 1 times 3 is 3. 2 times 3 is 6. Add these together. 3 plus 2 is 5 out of 6, or 5 over 6. And that's your answer, right? You can't reduce this any further. There's no number that you could divide out of 5 and 6 that are the same, right? So that's already fully reduced. Let's do another one. Let's say I have 3 over 4 plus 5 over 6. What do I do here? Well, 4, I can't really multiply 4 by something to get 6, right? Like a whole number. Because if you do like 4 times 2, you get 8. That's already too big, so I can't do that. But I have to think, is there a number that I could put 4 and 6 into, nicely? Is there a new denominator I could use here? And like the first question we did, where we multiply them by each other, you could do that. You could do 6 times 4 and 4 times 6. But there's actually an easier way to do it for this one. You don't have to actually multiply them. There's a smaller number that is going to work. And so what you have to do is think, okay, what's a number that has factors of 4 and 6? Or what's a number that 4 and 6 both go into, right? And the answer is 12, right? Because 4 goes into 12, and 6 also goes into 12. So you could use a common denominator of 12. So all you do, you say, 4 times what gives you 12? 3, right? 3 times 4 is 12. So you multiply the top and bottom by 3. Over here, what do you have to multiply 6 by to get to 12? 2, right? 6 times 2 is 12. So I multiply the top by 2 as well. And what are you going to get? 3 times 3 is 9 over 12. Plus 5 times 2 is 10 over 12. And then when you add these together, 9 plus 10 is 19 over 12. And that's your final answer. Now, some people might tell you that this is what's considered an improper fraction because the numerator is greater than the denominator. In my opinion, this is okay. This isn't actually a problem, and when you get to higher level math courses, that's not a big deal at all. But for now, your teachers might want you to fix this and make it into a mixed number. I'm of the opinion that mixed numbers are a little bit silly and just confuse people. So I'm going to leave the answer like this. If you want to change it into a mixed number, you can do that on your own. But I'm going to leave it like this. I actually like these improper fractions, and I don't know why they're called improper. I think it's actually okay to have it like this as a final answer. Now, let's go on to another example. Let's do 4 over 3 minus 2 over 7. So now we're subtracting, right? So first things first, what's a number that 3 and 7 both go into? I think you're going to have to multiply them together to get an answer, right? Times 3 and times 3, times 7, like that. So it's going to be over 21, right? Both of these will be over 21 because 7 times 3 is 21. 7 times 4 is 28, and 2 times 3 is 6. So I get 28 minus 6, that's going to be 22 over 21. And that's your final answer. Okay, let's do another one. Let's say I have 4 over 9 minus 2 over 3. In this case, it's nice because 3 goes into 9. So I can just make a common denominator of 9, right? So 4 over 9 minus 3 times 3 and 2 times 3, right? Because 3 times 3 is 9. That'll give me the denominator I want. And on top, 2 times 3 is 6. So I have 4 over 9 minus 6 over 9. 4 minus 6 is negative 2, and then over 9. So negative 2/9 or negative 2 over 9 is your final answer. Now that's all good. That's adding and subtracting, which in my opinion, adding and subtracting is actually more difficult than multiplying and dividing, which is good news because we're about to do multiplying and dividing, right? So let's do some multiplying. Let's say I have 4 over 5 times 3 over 7. Now trust me, this is going to be actually easier than adding is. So all you have to do is you multiply the numerators and you multiply the denominators. So for this one, 4 times 3 is 12. 5 times 7 is 35. That's your final answer. That's it. That's all you have to do. Nice and easy, right? Let's do another one. Let's say you have 2 over 3 times 1 over 6. Well, 2 times 1 is 2. 3 times 6 is 18. And that's your answer. Now, of course, you can reduce your final answer, right? So if you want to reduce 2 over 18, you can divide both of these numbers by 2, and you will get 1 over 9, right? Divide that by 2, divide that by 2, you get 1 over 9. So in reduced form, I would say that answer is 1 over 9. That would be your final answer. It's still pretty straightforward, right? So 14 over 5 times negative 12 over 13. I'm making the numbers a bit bigger just to make it a more challenging question. Otherwise, this is much too easy, right? 14 times negative 12 is negative 168. And then 5 times 13 is 65. And that would be your final answer. Let's do a couple more here. Let's say you have negative 2 over 5. And you want to multiply 1 over negative 3. What's going to happen here? Well, negative 2 times 1 is negative 2. And then 5 times negative 3 is negative 15. Now, this seems to be reduced already because you can't divide anything out of a 2 and a 15. So you can't reduce it. But the fact that we have a negative on the top and bottom, a negative divided by a negative, we know is a positive. So your final answer here, you should write as just 2 over 15. Those negatives kind of cancel out if you want to think of it that way. All right, let's do one more. Let's say I have 2 times a third. So this one's a little bit different, right? Because one number is a fraction, the other number is not. But keep in mind, every number is actually over 1. So think of it this way. So you have 2 over 1 times 1 over 3. 2 times 1 is 2. 1 times 3 is 3. So this is actually a pretty simple question, right? So whenever you have to multiply a number by a fraction, you can just multiply the tops. 2 times 1 is 2, and then leave the bottom the same. Or you can put it over 1 and think of it this way. 2 times 1 is 2. 1 times 3 is 3. So whenever you see a number times a fraction, don't panic. Just remember that all numbers are actually fractions, right? They're all over 1. Okay, that's multiplying. How about dividing? How do we divide fractions? It's probably something we don't really see a lot, right? Let's say you have something like 2 over 3 divided by 4 over 7. So for me, there's a way that I like to do these questions. What I'll do is I'll say, okay, 2 over 3. So what you do is you take this division sign and you change it to multiplication. And you're allowed to do this if you flip the second fraction. So 2/3 divided by 4 over 7 is the same as 2/3 times 7 over 4. And then you just multiply it like you normally would. 2 times 7 is 14, 3 times 4 is 12. And you can reduce this, right? Divide both these numbers by 2 and you get 7 over 6. So whenever I have to divide, I like to change it to multiplication and then flip the second fraction. Let's do another one. So let's say I had 1 over 2 divided by 1 over 4. That would be equal to 1 over 2 times 4 over 1, which would be equal to 4 over 2, which 4 over 2 is just 2, right? 4 divided by 2 is 2. And that's it. If I have 4 divided by a half, well, that's just equal to 4 times 2 over 1, which 2 over 1 is just 1, so you can just write it like that, and that equals 8, right? Nice and straightforward. Now they can try to write it in a way that's a little bit more confusing. They could say 1 over 2 divided by 4, so you have a little fraction divided by a number. This is needlessly confusing, right? What I would do is I'd rewrite this as 1/2 divided by 4, because that's what this is, right? It's a half divided by 4. So write it like this, and then of course you can say, well, that 4 is actually over 1, right? Because every number is over 1, and then flip it and change to multiplication. So a half times a quarter, which is equal to 1/8, or 1 over 8. So with this answer, can we maybe figure out a good rule to figure this thing out without doing all this work? What happened was we ended up just saying, okay, we had a half here, and there's a half here. And all you ended up doing was multiplying this 4 by this 2 to get 8. That's the only thing that really happened here. And so with this original question here, I think we could have said, oh, just multiply this 4 and 2 together, and then you have 1 over 8, and that's your answer. So that's actually kind of a little trick that you could use, right? So for example, if I have 3 over 4 divided by 5, I could use that same trick. 5 times 4 is 20, so your answer is 3 over 20. And you can do it the long way, the way we did over here, to show that that's true, right? You could say 3 over 4 divided by 5 is equal to 3 over 4 times 1 over 5, which is equal to 3 over 20. It's the same thing you get here. So instead of doing this long work, you can still do it obviously, but if you want, you can just remember this rule that you just multiply these numbers together, put it there, and then that's your final answer. So that's a nice little shortcut, which you don't have to use, but it's up to you. Okay, now what if I have a fraction like a half divided by a fraction like 3 over 7? So instead of divided by just a number, we're dividing by another fraction. Well, what this means is you have a half divided by 3 over 7, right? Which is a half times 7 over 3, right? Change it to multiplication, flip it. Multiply this out. 1 times 7 is 7. 2 times 3 is 6. That's your final answer. So if you notice, what we ended up doing was we ended up multiplying the 1 and 7 to get the top number. So this number and this number multiplied to get the top number, the numerator. And this number multiplied. And 2 times 3, this number and this number multiplied to get the denominator, right? So if you want to remember those rules, where you multiply these two numbers to get the numerator, and these two numbers to get the denominator, or the bottom, that's a good rule that you can memorize, right? So let's say, for example, you had 2 over 5 divided by 7 over 8. Instead of doing all this work, you just say, okay, I'm going to multiply these two numbers together to get the top. So 8 times 2 is 16. And then these two numbers to get the bottom. 5 times 7 is 35. So your answer is 16 over 35. And you can prove that by showing the work, right? You could say 2 over 5 divided by 7 over 8. You could say that becomes 2 over 5 times 8 over 7, and that becomes 16 over 35 when you multiply it. So instead of doing that work, you can remember that rule and just get straight to your final answer. Again, completely up to you, whatever you're comfortable with.